Hello everyone, welcome back. So today's question is, an object is falling freely under the gravitational force. Its velocity after traveling a distance h is v. If v depends upon the gravitational acceleration g and distance, prove with dimensional analysis that v is equal to k gh, where k is a constant. Okay, so we have to prove this equation with the dimensional analysis. Okay, we have given that v is directly proportional to g and h. If we consider the power of g is x and power of h is y, now substituting the dimensions of vgh, we get dimensions of vgh, we know the dimensions of velocity, that is L1 t minus 1, it will be directly proportional to, we know the dimensions of acceleration, that is L1 t minus 2, and we have taken the power is x, and the dimensions of h, that is L1, that is y. Now equating the powers of LHS and RHS, we get L1 t minus 1, it will be Lx plus y and t minus 2x. Okay, so we have equated these two dimensions. From that we get these dimensions. Now substituting values of x and y, if you consider this equation is first equation, substituting values of x and y in equation 1, we get this x plus y and 2x, x plus y is equal to 1 and minus 2x is equal to minus 1. If we solve this, we will get x is equal to 1 divided by 2, that is half. Now substituting this value in this equation, we will get y is equal to 1 minus x, and that will be 1 minus half, that will be the half. So we have got the values of x and y. We can substitute this in equation 1, that is phi is directly proportional to gx hy, we'll get phi is directly proportional to g power half and h power half. Okay, so we can write it as phi is equal to k under root gh. Okay, so from using the dimensional analysis, we have proven that phi is equal to k root gh, where k is constant. Thank you.